All right. Are we live? I think we're live. Awesome. All right. That was a hassle and a half getting that working. OBS and YouTube and the new YouTube live stream thing, they do not play nicely together. But it looks like we're here. So, today, well, okay. So before we get started, I'll let everyone know that I'm not talking about the SLS project today. That's still in progress, but it's where it physically is a pretty good metaphor for where it's at, because it's on a shelf in my closet. So the project is shelved at the moment. I'll get back to it at some point, but that's not a right now kind of thing. So today, what I'll be doing is let me flip this over to, let's see, come on. You can tell I'm a real pro at this. Okay, hang on. That didn't work. I'm trying to show you guys what I'm doing, or what I plan to be doing. Let's go back to Fusion. All right. And yeah. Let's put that right there. So this is what we'll be doing. So a friend and I had the great idea of designing our own version of what's called the Sisyphus table, which is basically just a magnetically controlled marble that rolls around on the table and draws in sand. So mute you. There we go. So you can see this is how it works. It rolls a marble around on sand and it draws out neat patterns, and it just does it over and over again forever. So I figured that this is just an XY plotter upside down with a magnetic ball attached to the end of it, so I can't imagine it's that difficult to do. But so I decided to try it myself. So let's flip over again to Fusion. There we go. Also, let me know if the music is working. There should be music, but I have no idea. If there's not music, there's not a whole lot I can do about it at this moment. So, actually, not here. I think there is. Yeah, I don't know why the music's not working, but it's not. But, alright. Oh well. Time to do the designing, though. So basically, I plan to make it an end table. So it won't be a full coffee table, because that just seems a little big for what I need. And also, I have a pretty small apartment, so I don't need it at the moment. And also, eventually, I'm going to be building two of these. One for me and one for my friend who had the idea with me. So we will... so I figured that this size of table would be the easiest way to make the fumbling of my words here. This is the cheapest option to make two of them. So just a couple of these are they're 3x3 legs, but 3x3s actually measure 2.5 by 2.5 inches. So they're so that'll be the legs. Then the sides are just 1x6s, and then I'm using thin plywood for the top and bottom. And here you can see I guess I didn't apply the appearance to this one, but there'll be a bottom plate that'll cover all the electronics, and then there'll be this top plate that all the electronics are mounted to, that has the rails and everything on it. So I did. This is the only part of the design that I really fleshed out, was the idea of this. So there'll be sand that goes up here, and then like glass that sits on top of here, so that way it makes it usable. Yeah, I'm reading chat. Yeah, the speaker output would work. the issue is I'm using a VLC audio source, and I have the YouTuber Wintergotten just made all of his music like free to use for everybody to use forever for non-commercial stuff. So I'm using his music for it, but for whatever reason, it's not. It's like it's just not working. It was working earlier, but it's not now. So, all right, you know what? Let's see what we can do about this. All right, if I remove the source and then re-add the source, maybe that'll do something. Yep. Do you guys watch the new Wintergotten 2 channel that he does the daily uploads on? Because that's exactly what I needed in my life, was more Martin's work. So I'm so happy that he's doing daily uploads now. But anyway, so for this, the idea is basically I'm going to take the typical MGN12 linear rails, make 3 of them in an H pattern, and then I'm going to make the belt path will be like an H-bot. So it's sort of a Core XY, but more simplified. It needs an absurd amount of rigidity for it to work, because there's a lot of opposing forces that have to cancel out and everything. But because it'll be bolted to the underside of a table, it'll have as much rigidity as it needs. So I think that this will work well. And if it doesn't, it's not that big a deal. I can always just make it Core XY, which that's like, it's just adding another couple of bearings and reprinting some parts. So I did have an idea for it, so I did model up something like this before. I did this the other day, but I wasn't liking the way it was coming out. I was using V rollers, but the size of the gantry and the size of everything that was doing, the size of everything that would have been needed would have meant that I would have had like a tiny little square of actually usable space in the inside, whereas using using linear rails would be, it frees up a lot of space. It means that I have a bigger print area. So all right, so let's get started. So I'm going to start by, let's throw a new component in here. Mechatronics 2. So for that, we're going to need some one of these. I need 3 of these, but I'll just copy paste that. I need one of these. I'll need one of these. And some idler pulleys. What size do you use? 16T. What size belt pulley is this? 6.5 millimeter. All right, so it's for a 6 millimeter belt. Measure. Come on. Diameter 9. Okay, so this is the 16 tooth pulley, which is exactly what I want. So let's throw that in there too. All right, and then I'll hide the data panel, and we can get going. So first thing we're going to start by doing is, I believe last time I used these, they were the wrong. They were sized for that. Yeah, 350 millimeters. So I'm going to need to break this link. And I plan to make these 300 millimeters, so let's take off 49 millimeters. No. Activate. There we go. I have a bad habit of just doing things without activating the component first, so that I end up with parts and bodies and sketches and stuff that have nowhere to live. So then the timeline gets all screwed up and everything gets all screwy. So I'm trying to not do that. Negative 49. Cut. Perfect. 350. Oh, that's right. There's a fillet on the end. So negative 49.5. No, I'm an idiot. What am I doing? Negative 50. Because there's a fillet on both ends, so I need to account for that. Okay. Jesus, that's a... Okay, 1 millimeter. Also, just a warning, I tend to curse a lot, so I'll do my best to not do that. But sometimes things slip out, so... I live in Philly. It is what it is. Okay. So now this is down to the 50 millimeters, or the 300 millimeters that it needs to be. So now I can make 3 of these. I can't paste that inside of itself. That would be dumb. So paste. For whatever reason, the origin's way out there. And paste. Okay. So, alright, so let's start by constraining some things. So let's throw that onto that, and let's make it a planer. Same with you guys, just you actually. And you're still a planer, yep, alright. And let's hide one of these, so that way we're not working on doubles. And let's hide the table, so that way we're not working over everything. So the main idea of an HBot path is, here, let me pull up the belt kinematics. HBot belt path. Yeah, this one, this will work. Open image in new tab. There it is. Okay. It's a bit blurry, but it is what it is. So there we go. So this is how an HBot belt path works. So it's, like I said, it's sort of like Core XY, where you have the motors mounted in stationary positions, neither of them move. And then depending on if they turn the same direction, opposite directions, or only one of them turns, it can make either X movements, Y movements, or 45-degree movements. So, and in this picture shows kind of the tension forces and how everything works. So if you turn this motor counterclockwise, if you turn both motors counterclockwise, it'll move only in the X direction, because this tension cancel out. So you end up with only a force in the X direction. So same thing, if the motors move in opposite directions, you end up with a movement only in the Y direction. So the issue is, because there's these two forces that have to cancel out, you need a rigid frame, otherwise the whole thing will rack and it'll just seize up. So, but like I said at the beginning, because it's mounted in the, because it's mounted to the underside of the table, it'll have as much rigidity as it needs. So, but for this, so you see there's the two motors in the ends that'll use the motor pulleys, and then there'll be two idle pulleys there on the far ends, and then there'll be 4 idle pulleys that the belt ride through to get to the X-axis in the gantry. So let's flip this back over to Fusion. So, alright, so the first thing we got to do is let's throw you onto there. Let's make that rigid. I could make it a revolute, but it doesn't really need to spin. And let's just arbitrary mount 10 millimeters just to clear everything. Yeah, that should work for now. We can always tweak this later. But so there's 10 millimeters for that. And then let's throw this idle pulley I really need to get 3D mouse. There. Flip. Oh, please. Oh, it's just the inside. I've never used. I just downloaded these reference models, so I haven't gone in and constrained them. In fact, let's just rigid group. Yep. And save. And update. Now this should. Yep, this moves as 1 now. So. Uh, 10. All right. I'm gonna need to tweak that. Oh, they're actually pretty close to lining up. Probably just another millimeter or so. Hey, there it is. All right. That's as close to lining up as it's gonna get. So. Okay, so let's start working on an adapter plate to mount the x-axis to what this is the y-axis. So let's start with a new component. XY gantry plate. Oh, jeez. Okay, well, it created the part. I hate that if you right-click, sometimes it does the drag and draw and pick apart thing. That gets frustrating. So, okay, there we go. Now let's throw a rectangle on this surface and arbitrary size. Let's do some projections. Nope, project the wrong thing. Project. Right. Everything that we need is projected then. And so I'll throw this disclaimer out there. While I am an engineering student, currently in my 4th out of 5 years, doing getting a bachelor's in mechanical engineering, I am not a professional at this yet. So it's so take what I do as advice, but not gospel. So I tend there are some things that I do that I'm sure in the professional world are just the absolute wrong way to do things. But I don't care because they work for me. So I tend to, if at all possible, do things by constraints, not with hard dimensions. That's from all my coding professors, all my CS professors over the years. They've always said no magic numbers, so I've just integrated that into the way that I program, the way I do CAD. So I try to do everything referential. I try to make everything based on something else, so that way, if you change one thing, it changes down the line. So that way, there's no. I don't really know why. I guess parametric design is the thing. So, all right. So these are just as I'm saying this, they're I'm using magic numbers, but that's okay in this case because I know that the hole spacing of this is 25 millimeters, and these holes are 3.5 millimeter in diameter. So it's I know that from using these linear rails so much. So that's what I just made him that. So okay. How big is this? Outer diameter. Diameter 13 millimeters. Cool. That's not the diameter that I needed. That's what I needed. 9.5 millimeters. All right. Circle. And if you don't know Fusion 360, these dashed lines mean that they are construction lines. Automatic Autodesk does this. Autodesk does what for you automatically? The constraint, the what I was talking about before. Words are hard. So right now I'm trying to project one of these faces. That's the one. So basically I'm going to I'm going to model in the belt just as a line. Oh no, that's not what I wanted. So I'm going to model the belt in as a line so that way I can guarantee that all the bearings and everything will line up. No, not a hole. Oh my gosh. Alright. And let's offset this by... Oh, make all numbers into parameters. Really? Okay. Why would you go horizontal? You were like 1 degree off of vertical. What is that? Alright. You're gonna be a pain, aren't you? Alright, let's just remake this line and just make it vertical. Alright, I see the vertical constraint has been applied. So then I can just make this as long as I need. Offset 2 millimeters. I know that ideally a GT2 belt is like 1.7 something millimeters thick, but I work in the real world, not in the ideal world, so I'd prefer to make it to give myself a little bit of slack, a little bit of room for things to for belts to be ever so slightly out of spec. Plus I buy the cheapest belts that I can, so yeah. Okay, why aren't you letting me move you? Alright, whatever. Alright, so this belt it loops around here. Okay. I gotta think about this. So the belt comes up, it comes around the motor pulley, up and around, and it'll go around this, but obviously I don't want the belt to follow in this center path because the other belt would need to go there too. So, let's make a rectangle. Let's make a construction rectangle that is the same size as these blocks. I love fusion, but sometimes its orbit mechanics are just complete nonsense. Alright. And, okay, sure, why not? Here we go. Okay, so make this 27. So apparently I can just rename dimensions as I go as parameters. Interesting. I'll play with that at some point when I'm not doing it live. So that way, when I can't figure it out, I won't look like an idiot in front of however many people end up watching this. So, okay, so let's say that... okay, so this is an important design milestone that I need to think about. So, let's finish the sketch and let's take a look at everything. So, the top, the table bottom is right here, right? Turn you on, turn that on. Table, not the bottom, sorry, this thing, gantry platform, that's what I named it. It's right there. This is flush up against it. If I make this mounting plate here, I can mount the X rail on this side of it or on the flip side of it, so that the bearing block, basically, so I can make it so the bearing block faces the wood panel, or the rail faces the wood panel. the bearing block faces the wood panel, then it needs then I need to use spacers, the thickness of the magnet. 3:20 or 12:26 a.m. here. Jeez, go to bed. Good night. Oh my gosh. Anyway, so I need to flip. I need to mount the rail here. So I can mount it to the bearing blocks facing the wood. But if I do that, I need to use spacers to lift it up off of the wood, so that the same thickness as the magnet, with plus a little bit of an air gap. So that way there's room for the magnet, obviously. Or if I flip it upside down, then I need to design a way. I need to figure out how to mount the belts and the magnet on opposite sides. So I'm going to need to design some kind of carriage that bolts to the top of the bearing block, but then also has fingers that wrap around it to hold the magnet on the flip side. So I can do that. I think that's the way I'm going to go, because that to me feels like the more right way to do things. Okay. What are you? Gantry plate, that's right. Let's flip you around. Okay. So with that decision made, I get back to finishing this design up. Let's make you... Okay, you're constrained to something that you shouldn't be. What are you doing? Apparently not. Okay. Alright, let's do this different order then. Who invited you to be wrong? Alright. So there's that. And there's that. For whatever reason, it wasn't letting me doing it the other way, but whatever. Let's make this coincident. Or not. Let's make that coincident. Or not, again. Yeah, I saw the other YouTuber, RC Lifeon, uploaded a video making one of these tables, and he had that issue with the ball not rolling on the sand, and his solution for it was just put a little piece of foam on the bottom of the... Oh, sorry about that, that's my cat's auto feeder going off. Okay. Sorry about that. I guess it's 6:30. But yeah, so RC Lifeon, he used a little piece of foam that he stuck to the bottom of the metal ball, so that instead of rolling on the sand, it was more plowing through it. But the patterns it made still looked really cool, and it still worked really well, so I'm going to just do that. So it won't technically be rolling, it'll be pushing its way through, but this is a table I'm trying to make myself, not a production company that makes these things, so I'm okay with that small concession. So, but thank you for bringing that up. I wanted to talk about that. So, wow, this is weird that it's not letting me constrain this, even though I can actually move it. Huh. Alright, I mean, I can work around that. And there we go. Now it's constrained. In fact, I could probably... Yeah, I can trim that and it's still constrained. Alright. So that means that this is the outside of the belt, so there's another... The belt will be here and here with the teeth. The teeth will be on this side. So I need to figure out some kind of mounting system over here, but that's okay. So I don't need that there. Alright. Alright, so then let's go to you. And I'll make you tangent to you. Tangent. And horizontal. Awesome. So now these two are aligned. The pulleys that I'm looking at buying for this have a 3mm bore for an M3 screw, so let's go 3.25mm, so that way the screw clears it and won't, you know, tap threads into it. And then 3.25. Why is my change parameters button not up there? I always use this. Oh, very cool. D303, so let's make this M3 screw. M3. No. Yep. Okay. M3. It's not autofilling like it normally does. It's not worth it. Oh, one too many undos. Okay. And then just to reduce material waste, let's taper this down. So this is, how big are you? That's not the right measurement. Still not the right measurement. Come on. 12mm. Cool. Duh, it's an MGN 12 rail. That was a boneheaded thing to do. Alright. And midpoint. You and you. And then yes. Yeah. So now let's make a line from there to there. Extrude the, oh, nope, wrong thing. Extrude you, you, and you, you, and you. Oh my. Okay. I must have misclicked. Okay, that's the negative direction apparently. And you. And you. Jeez, I needed to, I guess, project those as construction lines to make life easy. Alright. So now we're getting somewhere. Yeah, okay. So now mechatronics 2. Let's do some more constraints. Everyone's favorite. Let's put you on there. Rotate it around. So this is what I meant by I can mount it on this side or the flip side. So we'll see how this works, and if this ends up not working, then I can always change it. In fact, I can already see an issue that I'm going to need to run into mounting the belts, but that's okay. I can move things around. Let's take a hydration break. Whew. Alright, so now I'm going to need more of these. Where did you paste to? There you just pasted to. I'm going to need 2 more of those guys. Continue, sure. There's no constraint applied to this. If that doesn't move, okay. Let me do a constraint here first. Revert. Yep, okay, that's still aligned. So Shift J does as built constraint. So I'm locking those together, meaning that I designed them together, so I can just assign them assign them a joint together without having to specify points to align to. Alright, and then let's do here. Let's offset it 2 millimeters. Sure. Did I say 2 millimeters? I meant 1 millimeter. Yep, 1 millimeter works. Alright. Throw you on there. -1. Awesome. So now hopefully you can start to see how the belt path is going to go. If it's say for argument's sake it's mounted to this screw hole, it'll come down, loop around the back half of this wheel, come around, the teeth will engage with the pulley, go up and around this pulley, down, the back half will come around this pulley, it'll go through here without mounting to the block, and then it'll do the exact same on this side, around and around and around until it mounts to this screw hole here. Let's hide the joints because I don't like looking at them, they're ugly. Yeah. Okay. So I figure 5 millimeters is probably enough for this plate. I'm going to mount it with M3 screws going into it with washers, and I can. This is going to be 3D printed, so I'm going to print it at probably 100% infill. So 100% infill PLA mounted with washers should be rigid enough. If not, I can always go to Home Depot and buy some 1/4 inch like aluminum bar stock that they sell. 1/4 inch is 6 1/4 millimeters or so. So I can just do that and then transfer the hole locations and manually drill it with like my drill press and stuff. But I prefer to not have to do that. I prefer to just 3D print it if at all possible. Alright, so there's that side sort of done. Alright, so let's... Alright, I mean this is actually... Okay, so this side will just have a spacer here, but since it has these flanges, it doesn't really need anything else because the spacer will go through this bar and mount on the back of the plywood. It'll be another anchor point for this. So that doesn't really need anything else. I guess I need to make a motor mount. That would be useful. Okay, so let's bring the motor into play here. So I'm not going to be using a full NEMA 17. I plan to use pancake steppers. So I figure they should have enough torque for this because again, it's only drawing on sand, and it's drawing real slow. Like there's no like we're talking 10 millimeters a second kind of slow. Can you drill 100% infill PLA? Yeah. I mean, I guess because at that point it's just solid plastic. So especially if I use Pressure Slicer's new ironing feature, that it fuses the layers together even better. So it really would just be solid plastic at that point. So alright, how am I going to mount this motor? Huh. Interesting. Because I have a couple of options. I could use some really long M3 spacers and mount it up into the table. But that's a lot of leverage to put on that. And like I'm not planning on using paper thin plywood, but I am planning to use relatively thin plywood because the magnet has to go through it. Huh. I need to think about that one. Yeah, interesting. If I could mount the motor sideways... but now I'm getting into using bevel gears or like a worm drive to do that, and that's not really what I want to do. Although a worm drive would be pretty cool. And it would, but then the motors have to spin a lot faster, so they make a lot more noise. That's definitely not a worm drive. Let's see. I guess, huh. Alright, motor mount. I'll come back to you. I have other things to think about at the moment, but yeah. Yeah, I'll have to think about that one. So. Alright, you know, let's make life easy. Let's put you inside of you, and you inside of you. So now that's all one plate. So then I can just copy paste this over here. Scara style for the win. Absolutely not. I did actually think about putting a making the table have 3 legs and basically building a delta into the bottom, but we're getting dangerously close to just being really out there and over-engineered. Cool, cool. All right, where's this other rail? Oh, that's right, it's inside of this one. Which one are you? You're the original, so hide you. Revert. No, I can. Okay. Alright. Yeah, the circular one would be... The circular one, I mean, that's the way that the actual company who makes these does it. It's a circle. So the circle would be interesting. Well, that was my original thought. I was originally thinking about doing a polar system, where there'd be a motor in the middle. Yeah, sure. I mean, if you want ideas on Discord, if you yeah, go ahead and throw them on there. So, oh, that's you gave me a perfect segue to talk about the Discord. The Discord. I mean, there's like almost 200 people in there now. I've lost track of how many people are actually there, but there's a huge number of people that are all 3D printing fans in the Discord I created. So there's a link to join it down in the description if you want to be a part of everything that's going on and talk about this kind of stuff and chat with other like-minded people. Join the Discord. It's awesome. All right. Let's get rid of you. Where are you? Oh my gosh. Find in browser. Ah, that's why. Hide that. Get those visible joints out of here. None of that. Okay, so now... Ooh, I need to figure out what magnet I'm going to use. You guys can't see... Okay, cool. Making sure you guys... I'm going to Amazon, making sure you guys can't see what I'm doing until I decide to show you. Magnet. Were you really? You were the first member? I don't remember back that far, but I don't doubt it. Interesting. Well, I'm happy to have you along. Thanks for supporting me for so long. I very much appreciate it. Let's see. Alright. I figure a 1/2 inch in diameter magnet should work. I've got calipers right here. How big a magnet should I get? Now that I'm thinking about this. I mean, obviously neodymium, because ceramic magnets can go die somewhere. They hold nothing. Uh, no, but let's see. So, all right, what size magnet should I get? I guess. I mean, I have actually. You know what? I have some really big magnets already. I'm talking like, how big is that? Probably like 1 inch in diameter and like half to 3/4 inch thick. Like, and I have two of them, and they're the kind that if you put your finger between them, it hurts. Ask me how I know. um, yeah. You know what? If the music isn't working. How big a ball? That's another good question. It's a side table that's 18 inches square, so it would need to be a proportionally sized ball. Otherwise, like I don't want a giant 1 inch ball bearing in there because that just would plow through everything and be way too big. So, I mean, we can keep it the Wintergotten theme and go with a 16 millimeter ball bearing. So, would it be worth it to get a magnetic ball? So have a magnet on the gantry itself and also have a magnetic ball to double the amount. Oh, and also how thick a barrier. I was thinking 1/2 inch plywood. Yes, potentially. The microcontroller I was just going to mount on the so there's the plate that'll have the sand on it, and then the gantry mounted below it, and then there'll be a piece of plywood below that won't have any ties to the electronics up there, to the mechanics up there. So I was just going to mount the electronics to that lower plate. Again, the magnet's moving so slow that I can't imagine it's going to induce any currents in anything. And it's not moving directly over any big wires. So I don't think it'll be that big of a problem. Yeah, I could make a Faraday cage, that's true. A Hallback array. All right. I don't know. I think that that might be a bit that might be a bit much. When my friends just texted me, when is the stream starting? Well, it's been going for almost an hour. But since the music isn't working, let's change this tag here, the subtitle. A little self-promotion. Anyway, all right, I'll shoot you a message tomorrow and get you to model up whatever you're thinking about. Magnetic ball. I think. Magnetic ball. Is that a thing? Yes, they are. They're stress relief toys is how they're marketed. I could get a colorful one. Hang on. All right. All right. I'm a screen code plus camera. Sorry, I'm trying to show you. I want to show you guys what I'm looking at, but I'm on Amazon, so like I don't necessarily want to show you everything of what I'm looking at. There's some parts on here that are. All right. Don't get a magnetic ball. Ah. Oh, Danny, you're okay. I'll talk about it. So, he wants to know what's the next issue or bottleneck with the SLS. Um, I'm getting. Okay, so the issues that I'm running into with the SLS, I'll talk about that for a few minutes. It's so it's not distributing the powder evenly. The roller works to level it out, but there's still excess powder getting everywhere. So I would need to figure out something to do with that, but that's doable. But the powder delivery system that I was using, where a servo pushes out a dropper that puts a measured amount of powder out, wasn't consistently delivering the same amount of powder. It was delivering sometimes the right amount, sometimes way less. Um, Permanent magnet from stuff. All right, sorry, I'm getting distracted by chat. um, so the powder wasn't delivering evenly, and I didn't. A lot of powder was getting wasted and pushed into the waste bin, and then that waste bin needed to be emptied and put back into the reservoir. So I needed some way to recycle the powder up into the reservoir. And I haven't found a good way to do that yet. I looked at some like vacuum venturi systems to do it. I looked at some things like that, but there just weren't any that were, really what I wanted. So, yeah, it's still going. Plus, at the same time, I also worked on it for like 6 months nonstop. It was I woke up in the morning, worked on it until like 4 a.m. Went to bed, rinse and repeat the next day. It was all I did. It was all consuming for like 6 months. So I got kind of burnt out on it, and at some point I will go back to it. It's not dead. The project's not killed. I'm not Google. I'm not sunsetting projects. But for right now, it's kind of shut down. Yeah, powder is a huge pain to work with. It's it gets everywhere. Yeah, that was another part of it. I was kind of tired of my apartment always being covered in plastic powder and always smelling like toner. It was getting kind of annoying. Plus, like my cat would run through it, and then he'd leave black paw prints all over wherever he walked. So, let me reply to my friends. Let them know the stream is on. All right, sorry about that. My friends were asking about. Yeah, like I said, my friend was asking when's the stream starting, so I just texted him, "Hey, it's going. Go to my YouTube channel. You'll see it." So, okay. Anyway, let me flip to this. So, this is what I'm looking at now. So I think this is. I could get a colorful magnetic ball, and then I could use the magnetic cube underneath of it to drag it around. Yeah, you get a rainbow ball, change it for the time of year. Christmas time, put a red or green one on. Halloween, put an orange one on. That'd be funny. But all right. Sorry, I keep getting distracted. Um, okay, so I mean, basically, that's the gantry. So let's see how does it interact with the table. How are we doing there? Let's drag you over. Okay. That's not too bad. This platform will most likely be a lot higher because this is how far is this? Yeah, it's almost 70 millimeters. Most likely there'll be a 1 inch gap here, maybe inch and a half. So 25 millimeters, 37.5 millimeters for metric people. Yeah, so there'll be plenty extra room. Use a stronger magnet. So you're suggesting having a quick change magnet system so that so it automatically primes, so it automatically picks a different color depending on what's picked. Ugh, that's getting a little out there. See, I'm a fan of what I like to call beautifully elegant and simple solutions. So more features is just more places for things to go wrong. So I'd rather take a project, distill it down to the bare minimum of what's needed, and then work around those parameters before I start working into other things. So, but I do like the idea of quick change ball bearings. That would be funny. All right. All right. So, put manual. Yeah, we'll see. It depends on if I end up getting them, just like they use in fish tanks. What are they? I don't have a fish tank. So what do they use in magnetic? What are magnets doing in fish tanks? Oh, the kind where you like have a magnet on the outside and it has like a rag on the inside, and you like you move it around to get to clean it up. Yeah. Okay. Now I now know what you're talking about. Just, yeah, that would be funny. Or like I said, I could just, do one ball and just make it work. Focus on the project working before I get it to. Um, yeah, focus on the project working before I get before I start going fancy with it like that. Your image icon. Oh, yes, thank you. My friend texted me saying that the image is broken on the banner. Yeah, I know. I don't know how to fix it. I tried uploading my logo like 4 different times, 4 different formats. I changed the size. Like I made it down to like 15 pixels by 15 pixels, and I used the full size image that's like 2000 by 2000. I changed it from PNG to JPEG to well, just those two. But I tried so many different things to make it work, and it just every time I uploaded it, it just shows the broken image icon. So, and I also don't have a way to remove it. Well, I do. Hang on. The issue is when I remove it. Let's see if I remove. All right, we're doing this live, people. Here we go. JPEG and small version of it. It shows up in the preview, but when I click OK, it's still gone. So, it is what it is. Anyway. Okay, let's get this constrained to the actual table. So, you're 300 millimeters, so how big are you? 330, 20, so 1510. I mean, what am I? I can't do math in my head. 30, 20, 15, 10. Yeah. Okay. Yep. I was dividing the 30, 20, 30.20 in my head. Doing math live is never a good idea. Planar. Position. 15.10. Okay. So we're slowly getting down to it. How big are you from edge to edge? From you to you, 324. But how big are you internally edge to edge? Okay. All right. $44.375. Let's do some quick maths. 44.375. Yeah, continue, whatever. Let's see if my number crunching just worked. It's 675, not 375. 44.675. It's looking pretty even. What are you over here now? 44.07. Oh, so it was 375. Dang it. Alright. It doesn't also need to be perfectly centered for right now. I'm not doing anything. It doesn't need to be. But it is. Okay, so the idea is, ooh, I'm gonna need to do something about this. This needs to change its shape a little bit. Yeah. I tapered this down, but I think it just needs to be a T shape. Okay, I don't know why I just jumped like that. Why are things moving around on me? Oh my gosh. Stop jumping. Alright, if I just make that. Alright. Finish sketch. Change the extrusion to... If it jumps one more time. Oh, I need a linking line. Let's make these actually define shapes, as opposed to just arbitrary blobs. Whenever Fusion added its ability to... what's the word? Change... What do they call hotkeys? Sorry, I'm like, the second I try to think of a word, it just leaves my head completely. Like, I've never heard it before. But when Fusion lets you customize like key bindings and stuff, that was one of the best things they could have done, because then I made it. I made Shift F my finish sketch button, and that has been the best thing. All right, so now, there we go. Now we're getting all the way edge to edge. I can see though that I'm gonna need to push you out a bit. I need to drink more water. All right. All right, let's work on you now. Because let's hide the table. All right, let's work on the belt mount system for this. I don't even know what. I have no reason to have my headphones on. I just realized because the music's not playing and I can't hear anything, so I have no reason to have headphones on. Okay. Ooh. I do not like this geometry. How can I optimize this? How can I optimize this while maintaining that? Wait. Oh, yeah, that's right, because this has to wrap around. Okay. Whew. I thought I was being an idiot, but no, that comes later. Okay, so let's make a new component. Magnet mount. And this magnet mount is effectively where you put a hot end, or where you'd put a tool head. So let's project you and you. So, what's the general consensus on live streaming doing CAD? Is it remotely enjoyable to watch? Is it not? I won't take it personally. I'm just trying to figure out, because I have another idea for something that I want to design, but I'm debating on if it's worth it to stream it or not. If people will actually, like, you know, enjoy watching it if it's being streamed, or if it'll, or if people won't watch it. Wow. All right. Ooh. Do I have a magnet I could use? I don't have it here. All right, I'll do a placeholder size for now. Yes. But I'm gonna need to hide the gantry plates and that. There we go. There it is. So magnet will go up here somewhere, so let's go. Alright. Obviously not the final design, but let's start with something rough and then whittle it down to what we actually need. So okay, 5 millimeters, and let's make you also 5 millimeters. So magnet will go between these two lines, somewhere in there, and then the belt is going to mount out here somewhere. So let's work on that. I can make this 2 halves, then bolt on, and then pinch the belt between the bolting on of it. Yeah, no, my hair. There it is. Yeah, it's not a bad idea. Okay, so let's just extrude this for now, though, just to get an idea. Okay, and I'm going to need to go back into this now. Like I said, I was going to have to change this. Ooh, okay, so that's measuring off of the inside of the belt right now. So we need to add 2 millimeters. Okay, so I'm going to add 2 millimeters for the belt, and then we need to add 5 millimeters for the plastic that I just put there. So that's 7 on each side, so let's extend this by 14, so 27 plus 14. So 30, 41. Okay. Now, if I look down this, there should be... no. Something broke somewhere. What broke? Oh! That'll do it. There's no geometry there for it to mount to. That's okay. That is A-okay. So... let's put a circle... Sure, 7 millimeters. Why not? So there's 1. There's 2. Let's make these equal. Also, a little thing for Fusion, if anyone is ever looking to do like tangent lines really easily, if you do a new line tool and you click and drag from the circle that you want it to be tangent to, it'll automatically apply a tangent constraint. So like if I do a line, if I click on the circle and just drag out, it's automatically tangent. So I hope that didn't snap. Okay, cool. Equal. Alright, let's make you equal, and let's make you equal. And yeah, I'm working on that. I see your errors. Thank you very much. Yeah, I know I just got rid of this block, but I need to put it back for right now. What joint is broken? Miles using cast geometry and so on. What is broken? Where? Why are you running? What in the heck? What in... What? What is going on here? Oh, okay. Whew. I just misselected something. And it updated. Whew. Okay. I thought something was horribly, horribly broken. Alright. Let's reveal all. Oop. I need to do an implicit joint, or a as-built joint. View. Perfect. Alright, we're getting somewhere now. Okay, and yes, it's 2 millimeters offset like I wanted. Woohoo! It might not measure the right way. Woohoo! Minimum distance 2 millimeters. That's what I like to see. Alright. Okay. So now we're getting somewhere. So this is 1 millimeter offset, I believe. So let's make a small inner race for that. Yeah. Right click, please stop doing these things. Isolate. Yeah. Project you, and let's project you, and you, and you know what, let's do this too. Just, I might split the difference between them, because that's most likely the ceiling ring, which sits below the inner race in terms of depth. So yeah, let's just make it a round number of 5. Yeah, that works. Okay. Okay, I need to hide these guys. And extrude you 1 millimeter. And then let's put a nice 1 millimeter chamfer onto everything. There we go, that's looking nice. And there we go. So now when I bolt into this, it will be good. Awesome. I want to make this bigger. That doesn't look like enough meat on there for putting a nut on there too. 9. Yeah, 9 looks right. Why are you... Oh, wait. Oh. I forgot that I made that relative amount, or an equal constraint. Did that update? Yes, it did. Okay. It just looked the same. Okay, so then let's put a polygon inside of here. Circumscribe polygon 6. Arbitrary. I apologize if you hear the sirens around me. Like I said before, I live in Philly. Sirens are a constant. Alright, and from experience, I know that an M3 bolt is 5.5 millimeters wide, from flat to flat. What am I doing? Dimension. 5.5. And it doesn't need to be the full bolt thickness, just enough to retain it. So let's go -2. There we go. So now I'll be able to bolt into this. So now I'll be able to bolt these guys together without it being an issue. Alright. Oh, what am I doing? Unisolate. Alright, that's looking pretty good. Out of curiosity, I wonder how well does that line up? Oh, that lines up pretty well. I'm amazed. There have been 4 to 5 consistent viewers of this live stream. I'm impressed, because normally I would have 0. So this is good. I'm at least one of them because I have the stream open to monitor chat. So, but the rest, there's more people that actually are watching. I'm happy about that. Awesome. Alright. I need to figure out the belt mount now. So the belt's going to have to be clamped against there. Do I want to do it the right way or the easy way? I'm thinking the easy way. Yep. Yep, the easy way is the way to go. Alright. Ooh, that's not even going to be easy, though. Never mind, there is no easy way. There's the painful way and the less painful way. So to mount the belt, I could do a couple things. I could print out holes on the bottom for an M3 bolt to go up through, that then I would just wrap the belt around the M3 bolt, and it would... and then just use zip ties to hold it, and that would be that. Or I could model in the negative of the teeth, so that way the teeth lock into onto a flat. I mean, on the flat side, so that way the teeth. Is this going to be available for later viewing? Yep. Yeah. Once I'm done streaming, it'll be on the DVR. Words are hard. It'll go onto YouTube. It'll go onto my channel. So feel free to watch it later, whenever. 123 here in Europe. Okay. So next time I stream, I can possibly do a morning stream here. So that would be midday for you guys over there. Because I feel like there's a fair bit of people that I know, at least in the Discord, that are in Europe. So yeah, next time I do a stream, I mean, I can do it like early here. Because my classes this term start at noon, so I can do a morning stream. Yeah, I can do that. All right, so next time I'll do it in the morning, so that way I can get the European people to watch. So okay, but anyway, back to the belts. Uh-huh. Okay, so I could do, like I said, so I did that wrong, but here's what it is. Oh no, why did I make you as a daughter piece of that? No, you just go into mechatronics too. No. Stop. I didn't realize that it was there. Can you come out of that, please? It's not active. I'm not doing anything to it. Shoot. Alright, that's just gonna live there. Live inside of the gantry plate, I guess. Oh wait, no. It is in mechatronics too. These are just not. That's weird. Whatever. Hello, Juicy Coding from the Discord. Okay. Belt mounts. Okay, so if I put, because the belt, the teeth will face in, so the teeth will face this wall here. So I would need to put the negative of the teeth on that, and then I would just need to use some kind of clamping plate to bolt onto it from the outside. I like the idea of putting screws on though, and just having the belt be zip tied. So I think that's what I'm going to do, and I can just move those mounting holes again if I need to. So 3.25 for an M3 hole. Let's call it 9. And let's make you... Shoot, I forgot to make it. I forgot to activate that component again. There we go. Now I activated the component. Using. What do you mean tape change from Voron Designs? I'm gonna Google this right now. What do you mean? Oh, it uses a tape measure tape? Interesting. Huh. Interesting. Alright. Do I want to line this up with this? No, because that'll create a stress concentration. Yeah, that tape measure for cable strain relief. Not a bad idea. I might... Thank you for sharing. I might use that. Alright, let's make you 15. Yeah, that works. Ooh. Okay. I'll just do the same way I did before. In fact, yeah, there we go. Now we're cooking with gas. Alright, snap to that. Alright, so then the belts would come around here, grab on to bolts that come up through here, and then I need to mirror that. Let's do a mid plane, mid from there to there, and then let's create a mirror, and I do mirror features, this extrusion, over this plane. Enter. There you go. So now the belts mount there. I can hide this. And now all I need to do is move these pulleys to align with the new belt. Which, how far out do I need to put you? So there to there is 3 millimeters. Yep. So 3 mils. Let's add an extra 6 to this, so 47. Hey, and that updated. Good shoot. I had to censor myself there. Okay, that's looking good. And then does I still get the majority of my travel, and I can always move the motor back if need be. Same with over here. Okay, now let's work on a different part of this now. Let's make this work with this. Okay, so this is 5 millimeters tall. I made this gap 5 millimeters. Let's make it 6. That way there's an air gap so it can actually slide over it. What am I doing? Go away, Windows thing. Okay, so I made that 5. Let's make that 6. Planning doing more live streams in the future? Yes, absolutely. So there's one of two places that you could find me streaming. So if it's like a technical thing, like doing CAD design or building something or that kind of stuff, it'll be on this YouTube channel. It'll be right here. If it is gaming or something more along those lines, it'll be on me and a few friends have a Twitch channel together. It's called Obungus TV. I'll throw a link to it down in the description after I'm done here, so everybody can see it. Yeah, so you guys can come in and watch us play games. I've been playing Satisfactory lately. I don't know if anyone knows what that game is. It's an early access right now on Steam. The entire point of the game is just build factories. So you use conveyor belts and assemblers and constructors and like miners and stuff to gather resources, process them into other resources, and then turn them into more products to build more things. So we've been playing a lot of that lately. We also play Risk of Rain. We play a couple other things. So if you want to watch us there, watch us over on Twitch. If you want to see the more technical stuff, come to this channel and stream, and I'll be streaming here. So we can talk more in the Discord about it. Figure out a time that works for everybody. Because it's when I started it was 6 p.m. here, so I figured that would be a good like off work time. But then I'm in the Eastern time zone, so I don't know where everyone else is, where the majority is. I can stream at a different time if it works better for other people. So yeah. All right. So let's do something about this now. I forgot to activate it. Gantry plate 1. That's you. Yeah, continue. I want that face. Whew. I'm also getting hungry for dinner, so let's hope I can finish this up soon. Okay, I want that to be construction lines. That was annoying, but okay. Alright. So do I just cut that away? No, I don't just cut that away. That's kind of my bounding line. So I can sweep in here. Let's project that line and that line. So, okay, I have the material that I want then. In fact, let's make those real lines, not construction lines. Oh my gosh, why is this so difficult? Why is it putting up a fight with me making them construction lines or not? Okay, and if okay, so for the electronics, I was planning on doing, what are they called? SKR Mini E3s? I don't know why I'm doing plural. I'm one of them. I plan on... Oh my gosh, sorry, this is... normal. Okay. You've lived a life. There we go. Okay. Sorry. Yeah, I'm gonna do a SKR Mini E3 just because it's silent. It uses the TMC 2209s, so it'll be super quiet, and it does everything I need it to do. So it doesn't. It's 32-bit, so it's future proof because maybe someday I'll repurpose this for something else. So I can, if I ever want to build a printer out of this. I mean, these are all printer parts, so I could always just take it apart and do that. Yeah, I think that I'm looking over there because I have all my printers are over there. So I'm looking over there. Yeah, the SKR Mini is I think what I was going to go. A ramps board. I don't know. I've used ramps before, but I don't like the stack up of an Arduino plus a ramps plus steppers or stepper drivers. It ends up being kind of unwieldy to deal with, whereas a single board solution, it's a little cleaner, a little nicer. So, but we'll see. Maybe I've even thought about doing like a CNC stepper shield for just an Arduino Uno, but I want to be able to run Marlin. Because this is a Core XY system, or it'll pretend that it's a Core XY system. So, what printers do I have? I have Prusa Mark 3S, and I have. Okay, so I have a couple. I have a Prusa Mark 3S. I have a resin printer. It's a longer Orange 10, and I have a printer that I built, that I designed and built. That has a really big build area. Those are the three that I have here, and then back at my parents' house I have a Monoprice MP Select Mini, a Fabricator Mini, and what's left of a Tron XY or Tronxy X1. I've kind of scavenged parts off of that, so that's not really anything left over yet, anymore, but I still count it. Okay, so there's something. And then what if I fillet this edge? Do you guys say fillet or fillet? I have no idea how I'd know how you're typing it in chat. So type out how you say it in chat and I'll guess. My teacher in high school who introduced me to CAD, he said fillet. So that's how I've always said it. But I'm interested to know if you guys say something else. Okay, so there's that. Okay. I don't know. I'm not liking that. Fill it like Gillette. Okay. Yeah. I had a friend in high school whose family was from England, and his dad was an engineer, and he would correct me every time I said solder instead of solder. He would say, "There's an L, why don't you pronounce it?" So I'd say, "There's an S in Island, why don't you pronounce that?" I don't have a punchline or something funny with that story, it's just something that happened. Okay. I'm kind of liking this more if I put the lines here. My cat is freaking out. We're supposed to get some snow overnight here. So they're salting everything. So there's people outside salting and doing everything. Come here. The people want to see you. So, here's the cat. Fillet like fillet. Okay, it seems like the consensus is fillet. Just fillet, not fillet. So this is Bibbles. This is the cat. All right, he has made his appearance. He's going off to do cat things. So, okay, let's make some more lines. You know what I haven't done in a while? Like this entire stream? Saved. So let's fix that. Cat. You don't know it, but I don't have a voting machine, but I joined the Discord. Yeah, okay, that's fine. Get rid of that fillet. I see. It's easier to do that. Okay. There we go. Now we're getting somewhere. Is it ugly? Possibly. Do I care? Not likely. Bibbles don't give a hoot. Yeah. Okay, so there we go. Let's show all. Show all bodies. Show all components. And let's activate you. Okay. Bottom plate can be hidden again. So, oh Jesus, I forgot that I have Mechatronics 1 in there. Okay. So this is where we're at. So I still haven't figured out the motor mounts. They're just kind of floating there. Anybody have any suggestions for the motor mounts? Because I really don't like the idea of just a really long spacer up to the table. Were you able to find the fusion files for rail/motors? GrabCAD. Anytime I need any kind of file, I just go to GrabCAD, and you can make it's free. You can make an account, and there's most likely a file for it. So yeah, it's GrabCAD is the best place for that kind of stuff. So, and they're usually people upload them in like solid part or step files. So they're easily usable in other apps. They're not STLs. They're not, something that's just they're like OBJs or anything that's really not useful. They're pretty good. Ugh, excuse me. Okay. Okay, so you know what? If I just leave this hole, I can slide it on before I mount the other side, and then this block, I'll just bolt in from this side. The magnet will mount on the flip side of that, and then control a ball through the table up here. Let's see. Okay, we're getting somewhere. Let's model a ball. Let's make a new part. Ball bearing. Yeah, I know parts have moved. Something that I do that I don't know if other people will do this or not. If I am planning on using a constraint, like I was planning to use a horizontal vertical constraint on there, I will, I'll draw it like this. I'll draw it very wrong, so that way I know that I haven't constrained it yet, as opposed to drawing it almost vertical, but just not quite snap to the snap point. So I don't know if other people do that or not, but that's what I do. All right, let's call it a 16 millimeter ball, just for funsies. Do I really just say funsies? Axis. All right, so there's a ball. Let's constrain it to. Oh, let's hide this first. Gantry platform. I did the same. Yeah. Yeah, I kind of had a suspicion that other people did that. Okay, there's that. Let's turn on the gantry platform. Let's make the ball. Okay, this ball's going to float a little bit. What constraint did I just use? What in the heck? So oh, it was a planar. I needed to be a rigid. That's why. Awesome. And then I can hide that. And yep, the ball moves the axis. Very nice. If I really wanted to get fancy, I could set motion limits so that way the thing won't actually go any farther than it physically can. But I'm lazy. No, if okay, here we go. If motion links, or if not motion links, if contact bodies work, I'll try that. So what are you? You and you. Assemble. Enable contact sets. Right click, new contact set. Yeah. Okay. And it didn't work. Do they even touch? Yep, they touch, and it just doesn't work. Cool. Neato. Alright. Well, that didn't work. That's okay, though. Contact sets. Don't care. Assemble. Disable contact. Yeah, it's just, there's, what's the inspiration for this? The inspiration for this is the Sisyphus table. So it is, give me 1 second to flip over to, or not. Okay. It's not working to let me show you, but if you Google the Sisyphus table, that's what this is. Ah, now it's working. Okay. This is the inspiration. So the idea is it'll just draw up patterns like this. So, and in fact, it'll do more than just draw patterns. So my friend would get mad at me if I didn't talk about so I say this is a joint project between me and a friend. So the friend would get mad at me if I didn't explain his contribution to it. So he is a CS major, and so what he did is he wrote software that can take an image, can identify the edges of objects in the image, and then he wrote a pathing algorithm to trace out a path from one start point around all of the image, around all of the edges in the image, with as few connecting lines as possible. So instead of like a 3D printer, how it'll dart around to do little dots everywhere. If you try to like do like a lithophane or an image, this it'll be one path through the entire image. So the idea, then the idea is he'll take a picture of things, and then then we can upload it to this in G code, and it'll trace out like someone's face or whatever you take a picture of. So, yeah, next time at some point, whenever I actually buy all these parts and actually build this thing, I'm probably going to live stream that too, and I'll see if he wants to come on and talk about it a little bit, because he created the script for it. So for the pattern, like the circular patterns and stuff, there's a website that generates G code for that. So that's what I use for the simple patterns. But for the image processing stuff, that's all an app that he wrote for it. So yeah, this is it's really, really cool. So, all right, hang on. This is bothering me that this is a different appearance. Let me hang on. Okay, there we go. Sorry, that was bothering me to no end. All right, Juicy Coding, thanks for stopping by. And yeah, my cat would be confused if it was just a picture of him on there, which, knowing me and my friend, we would probably do that. I'm sure that Bibbles, my cat, would be a good test subject for that. I don't know where the cat went. He's off in the cat dimension somewhere, as they do. Okay, turn on that body. Okay. And let's put a steel texture on this. Steel. Polished stainless steel on the ball bearing. There it is. Let's see. How does this look in the render? Oh, excuse me. Other than the motor sticking on the bottom, but like I said, I'm going to use pancake steppers, so. But, yeah, this is looking pretty good. Let's hide the bottom. And let's do a wireframe so we can see. Yep, when I move the ball around, this moves. Very good. Okay. So the belt pathing is taken care of. Belt mounting is taken care of. Bearing mounts are taken care of, except for these ones, but that's just a cylinder, so that's honestly easier to just... Like, I can do that later. That's not worth doing on stream. So next up really is the motor mount. Ugh. This is the part that I've been not necessarily looking forward to. So, okay, with the motor, how can I do this? So the motor, I could try even mounting it to the leg, because it's pretty close to the leg here. Any kind of raking built in, or you just shake the table? There's a specific path that it can follow where it starts in the middle and it spirals outward. So that clears the image. You know, it clears the image. I mean, if really needed, I could shake the table, but spiraling outward or doing even like a rectilinear infill basically, so it just goes back and forth. Something like that would work too. So, all right, motor mount. Yeah, because even if I do use some like long extensions, it's the gantry is going to run into them as it as it approaches its limits. Because, like, right there really is the limit of the gantry. So, and that would interfere with this one and almost that one. So, interesting, interesting. I could, no, I don't like that idea. I was going to say I could mount it to the bottom plate, but I have no way to get to it then. No way to actually attach the screws. So that's not a good idea. I don't know. Okay, so the... Alright. Alright, you know what? I'm gonna say that this is pretty close to done at this point. I just need the motor mount and then the electronics mount. But the electronics mount, I have to wait till I actually get the electronics because I need to, I need to figure out what I'm getting. So, yeah, if you guys want, I can live stream. I say if you want, but I'm doing it anyway. When I do the actually assembly, when I get all the parts and print out all the parts, I can yeah, I'm gonna live stream that. Recess into the leg or bracket going. That's my thought, is it could be mounted to the leg, but the issue is my woodworking skills are not that great, so I don't want to rely on the precision of that. I'd rather, like, I can mount everything to this plane here because it's a flat plane that I can use, whereas if I need to do the leg, that means that the leg has to be mounted at 90 degrees, like it needs to be exactly perfect. So I don't know. Yeah, I'll have to think that one over. Maybe there's another way to do it. Maybe I mount the motor upside down so that the butt of the motor, the back plate here, is up against this. And then I use a rod with a bearing here and just a small belt to connect the two, and then a long belt that goes from there around the whole belt path. Sort of like how Ultimaker does it, where they mount the motors somewhere different, and then they use just a short loop to connect the motors to the actual drive system. So maybe something like that, but we'll see. I'll have to think about that one, but it's been 2 hours. I've kept you all here long enough, so I'll say thank you everybody for stopping by. It was a lot of fun talking to everybody, a lot of fun streaming like this. So I'm definitely going to do this again at some point. My next plan for a design stream is I want to design a 3D printer from the game Astroneer. They use printers in that. Look it up, but I'll explain it in the stream. But they use 3D printers in the game to make things. Like the crafting table in Minecraft, but in space games. So the 3D printer, the way they show it working in there, it's dangerously close to being a real thing. So I want to see if I can make it real. I want to see if I can make it work. So I'm going to design that next. But for now, but for now, this is where I'm at on this, so I'll keep you guys updated on the Discord as this project progresses. So thanks everyone for stopping by.